Welcome to Math Made Easy. Sometimes a single, seemingly random date can act like a key that unlocks this hidden network of incredible stories. Today, we're diving into one of those dates, March 17th. It might not sound like much, but as we're about to see, it connects an amazing range of scientific breakthroughs across centuries. It really weaves a story about discovery itself. So let me ask you this. What in the world do fluid dynamics, the birth of modern software, and the sound of a passing ambulance all have in common? The answer, and it's a surprising one, is they are all tied to March 17th. In this explainer, we're going to unravel the stories of the brilliant minds connected by this one day and see what it tells us about how progress actually happens. All right, let's start our journey in the world of classical physics. March 17th is a day to remember several foundational scientists whose work just completely changed how we see the physical universe around us. Okay, so check out this contrast. On one hand, you've got Daniel Bernoulli. He was basically born into math royalty, part of this famous dynasty, and he's the guy who gave us the principles behind how fluids flow. On the other hand, you have Christian Doppler. His family were stonemasons, but he was considered too frail for that kind of work, so he went into academia instead. Two completely different worlds, yet both of these giants died on March 17th and both left a monumental impact on physics. Now, Doppler's biggest claim to fame is something you and I experience all the time. You know that neom sound a police car makes as it races past you? That change in pitch? That is the Doppler effect. And today, it's a fundamental concept we use in everything from weather radar to astronomy, all from a guy who was once told he wasn't strong enough for physical labor. Amazing. And the list for this era doesn't even stop there. Also passing away on March 17th was Wilhelm Bessel. Now, if you've ever taken a physics or engineering class, you've probably run into Bessel functions. They're basically these special mathematical tools that let us describe really complex things, like the ripples in a pond or how a drum head vibrates. Just another giant of the physical world, forever tied to this date. Okay, so let's jump forward in time. It's kind of wild, but the same date that marks the end of these classical physicists' lives also marks the end for pioneers who built the very foundations of our digital world. This is so cool because here we have the two essential sides of computing. First, you've got Henry Scheffer. His work with the NAND operator, the Scheffer stroke, is a fundamental logic gate. This is the literal bedrock of how a computer chip thinks. Then, decades later, on the exact same day, John Backus passes away. He's the guy who led the team that gave us FORTRAN, the first major programming language. It's what allowed us to translate human ideas into something that hardware could actually understand. You have the hardware and the software, both linked to March 17th. And the origin story for FORTRAN is surprisingly down to earth. John Backus wasn't on some grand mission to change the world at first. He was just a music lover who wanted to build a really great hi-fi stereo, but doing all those tedious calculations for the amplifiers sparked this idea. There had to be a better way to make computers do the heavy lifting, and that little personal project ultimately led to FORTRAN. This quote from Backus just captures the spirit of invention so perfectly. It's not about one single aha moment. It's about perseverance. This willingness to fail and fail and fail again is a thread connecting him to Bernoulli, to Doppler, to all of these pioneers. It's the hard, grinding work that happens behind every breakthrough. So we've seen physics and computing, but the legacy of March 17th goes way beyond Europe and the United States. It's a truly global story, spanning different continents and all sorts of fields of study. Just look at the intellectual diversity tied to this one date. It's incredible. You've got Backus, who's revered as the father of differential geometry, that's the study of curved spaces, in China. Over in Scotland, Alexander Morgan fundamentally reshaped how math was taught for generations. From Hungary, Laszlo Toth was a master of geometry, figuring out how shapes can pack together in the most efficient ways. And way back in Germany, Karl Hindenburg started an entire school of combinatorics, the math of counting and arranging things. Each one was a titan in their field, all connected by this single day. Wow, that is such a powerful statement from Backus. For him, math wasn't some abstract puzzle. No, it was directly tied to the future of his country. It just goes to show you that the drive for discovery can be deeply personal, it can be patriotic, and it's always profoundly human. It gives all the numbers and equations a real soul. Okay, so we've looked at physicists, computer scientists, and mathematicians from all over the globe. What's the common thread here? What's the one thing that weaves all of these incredible stories together? Well, at the end of the day, it doesn't matter if it was Bernoulli watching water flow, or Backus tinkering with a stereo, or Sue working to build a nation. They were all driven by the exact same fundamental human impulses. This insatiable curiosity, the grit to push through failure after failure, and a deep desire to find the elegant patterns that govern our world. So, what's the big takeaway from this journey through a single, remarkable day in a history of math and science? In the end, March 17th is like a perfect little window into the whole story of science. It reminds us that progress isn't some straight line, and it's not confined to one country or one type of person. It's a global, interconnected story built by people from all walks of life, all driven by passion, persistence, and a shared sense of wonder. It's not just about equations, it's about people. One single day holds all of these incredible legacies. It makes you wonder, doesn't it? Who, right now, is sitting in a lab or at a desk, working on the next breakthrough? What discovery is being made today that we'll all be talking about 100 years from now? The story is always being written. Please like, subscribe, Math Made Easy channel.